Hey everyone, Sam here. Let's do another programming puzzle question. Okay, so if you're new to the channel or you come from the Chessboard to Tech series, this channel originally started where I would do tech interview questions, kind of like you do for phone screens or on-site interviews. And I've been kind of interviewing and interviewee for over a decade. I think it's a fun way to learn algorithms, and if you're kind of crazy like me, I think algorithms can be just really fun to learn on their own. So anyway, I'll start the timer in the top right, and feel free to follow along on this question. I'll have the link in the description. And it looks like we're doing number 1827. You're given an array, integer array, zero index. In one operation, you can choose an element and increment it by one. So if you had like 1, 2, 3, you can choose to increment the numbers in number 2 to make it 1, 3, 3, sure. And return the minimum number of operations to make the array strictly increasing. And here strictly increasing means that every number in order is always always greater than the previous one. It can't be the same. So you couldn't have like 1, 1. You'd have to have 1, 2. And it could be 1, 3 also. That's valid. So for example, if we're given 1, 1, 1, it takes at least 3 operations because you have to increment the second one by 1 to make it bigger than the first. And then you have to increment the third by 2 to make it bigger than the second. And here they actually did it in a different order. But I'm already starting to think about a way to solve this problem because on its face it could be really complicated. But we don't want to get ahead of ourselves. That's number one in an interview, is you want to fully understand the question. And here, when you're looking at it on a page, it's not, you don't really get that much back and forth with the interviewer, but you want to make sure you understand them and kind of repeat back what they say to make sure you're on the same page. Because there's been a lot of times I've given an interview with something like this where you might say strictly increasing and the person just hears has to be at least the same or bigger, and then they mess up because it's the same number. And we can fix it later on, but sometimes you can get stuck down the track, and you could save yourself a lot of time and headache if you just kind of repeat back what you hear from the interviewer. So that'd be tip 1, I'd say. All right, other example is 15241, and it takes at least 14 to increment them all. I'm assuming that's true. And then the third one, that's kind of an interesting question. If there's just one number in the array, you don't need to do anything to make it bigger. So the questions you want to kind of ask here is, what is the edge cases? Like, what if it's an empty array? Does that count as 0? Another question you might ask in an onsite is, what if the size of the array doesn't fit in memory? This kind of does matter when you are dealing with, big scale kind of stuff. You'd want to break up the problem into multiple different bits, but on-site questions and phone screen interview questions, you're rarely going to get that, but it's nice to kind of have an answer if the interviewer kind of asks about edge cases and stuff like that. The other question is, what if the numbers aren't numbers? What if they're nans or anything like that? In Python, you can do that. In C++, I don't think as much. What about negative numbers? Do you need to worry about that? In this case, they're all positive. They're all going to fit inside of an integer. If you had floats or something like that, how do you deal with like what's it called, mantessa, whatever, the tiny error between two float numbers that are very close to each other? This is all, things to think about. Make sure the interviewer does or doesn't care about that, and then you can start talking about the algorithm. So in this case, it seems pretty straightforward as is described, so that's good to see. I kind of want to start thinking about what I want to do here. So before I write any code, I'd like to think about what kind of algorithms I do. So let's have a look. I should be able to show this on hold on 1 second. Let's start a video here. All right, hopefully you guys can see this. You can't see me over here, sorry. But over here, what I'd like to do is think about different approaches. So let's just say approach 1. Oh, I don't like this pen. How about this one? Yeah, approach 1. So kind of what I'm thinking is, if you have some number array like this, and all you care about is that each number, let's see, A, B, C, A has to be greater than B, and can you read that? Yeah, this is some beautiful handwriting. And B has to be greater than C, and so on and so forth. You don't really need to worry about B and C until you fix B. B doesn't care about C, so you always can kind of go in order of the array when you're trying to make any changes. So when we were looking at the example 1, they incremented the third value in the array before they incremented the second. But I already was thinking you don't need to do that yet. because you don't know what that second number is until it's satisfied the constraints of the first number before it. So every number is only constrained by the number before it, so we can kind of go in order. The first number, we're good to go. We don't really care about it. All we care about is making sure that b is greater than a. So the first step is increment however many times for b to be greater than a. And actually that number will just be, let's see, b minus a, if they're exactly the same, it would be 0. So you'd always want to be at least one more than that. So b minus a plus 1, I think, is the number. Wait, let's retry that. Let's say b was greater than a. B minus a would then be greater than 0. So actually we want a minus b. And then if a is bigger than b, and actually, yeah, so let's just think of 3 different options. Let's say a was equal to 1 and b was equal to, 3. Then a minus b is equal to 1 minus 3, which is equal to minus 2. We don't need to do anything, so we could actually take the the min of 0 and that, and that'll give us the min of 0 and minus 1 minus 3, and that'll be 0. That's great. But now if we do it the other way around, let's say a was 3 and b was 1. Now the min of 0, can you still see this? Cool. A minus b would be 3 minus 1, which would be, in this case, 2. Min of that is, can't do min, sorry, max. You may have caught that. What I meant to say was the max of that. So the max of minus 2 and the 0, it will be 0. Otherwise, it would have actually been minus 2. Okay, so max of 0 and 2, in this case, would be 2. It would take 2 changes to bring b up to 3, because it would be 1 plus 1 is equal to 2, plus 1 is equal to 3, and that's not enough, so we actually need to increase that by 1. So it'll be a minus b plus 1, I think, is going to be our final equation. And I'm kind of just doing this right here because I don't want to start writing the code just yet. I want to just kind of make sure it works. So let's try for this same question. If a is equal to 3 and b is equal to 1, 3 minus 1 is 2, plus 1 is 3. So we get a total of 3 in this case, which would be correct because that would get this to 4. So that would give us an answer of, a is 3 and b is 4. But what happens if, let's say, a and b were both equal to 1? 1 minus 1 plus 1, that'll equal to 1. And that is correct because that'll be to get a is equal to 1 and b is equal to 2. Okay, I'm feeling pretty good about that. We can just use this little formula to calculate the difference, the amount of operations needed to convert the value of b to a. And then we just need to do the same thing from once we've changed b. And actually we do need to change b to be that value, so we can actually add it to the array and keep track of it that way. And then do the next thing for c. So then we have to do the max of 0 and let's say, b minus c, and this is going to be the new b, plus 1. And we'll kind of increase all the way this way. We want to keep track of the total ops. And we also want to update the current number. We could update the whole array, but that would be O of n space. So let's start actually going back over here. We're about 8 minutes in. I haven't written any code yet, but I've kind of talked about what I'm thinking. Are there other approaches? Absolutely. I think one of the other approach, let's just make sure we have our first approach. Approach 1 is keep sum of ops needed. Let's call this, like ops equals 0 to start. And then iterate through array starting with second. Count ops to convert. Let's call this, let's say if array the nums is equal to x0, x1, x2, so on, like that. We'll say the count ops to convert x of I minus 1, x of I. Count the number of ops to convert x of I so that x of I minus 1 will be less than x of I. And I think let me write that over here too. So x of I minus 1 to be less than x of I. And that's the same thing as saying a less than b. And we could do that, and that will be our kind of iterating through the array will be O of n time to go through array. But we also want to keep track of the new value after we've changed the ops, because if we don't update b, then it won't, like if we had to update x of 1 to be greater than x of 0, when we're checking x of 2, we have to make sure x of 1 is also increased. So I think we can just keep track of the last one. We don't need to store everything. If we were to store all of the updated values, we could technically update it inside of nums. So that is still, is that creating a new array, a new space? Not really. So we can start simple there. So let's just do our for I in range, the length of nums, and there are faster ways to do this, but I'd like to go from the first value through the whole value, through the array. So we're skipping the first one, and we'll check if a is equal to nums of I minus 1. So that'll be our I minus 1, and b is equal to nums of I. And then ops equals the value we had from earlier, which was 0 and a minus b plus 1. And then what we could do now is, let's see, current ops, let's call it, or let's call this total ops, and we'll just keep this as ops. And then total ops plus ops. And we also want to update nums of I with that value to change it, basically, because that's how much we have to increment it by. And we can keep doing this all the way through the array and just return the total ops. And so here we have our O of n time to go through array. We're technically using this passed in array rather than a new one, so we're not creating any new memory. So I would say this is O of 1 space. And in fact, we don't have to update the array. We could just keep track of the latest, like the last number, and use that. So we might do that in a minute, so we'll see how that goes. But I'd like to think about this for a couple seconds. Is there any other edge cases? What happens when there's just a single value in the array? So that means that we will not iterate at all, and the total ops is 0, which we return, and that's correct. What happens when we have negative numbers? We should still have the same difference between the two of them. I think that should work. We're about 12 minutes in. I think I'm feeling relatively good about this. We should walk through the 1-1-1 case just to be sure it'll work. So let's think about it. How about here? So we have our 1-1-1, and in fact I have to do it here too. Okay. So first we go through our for loop. For I is equal to range 1, so let's say I is equal to 1. A is equal to the value at I equals 0, so it'll be nums at 1 minus 0 equals nums at 0. And I'm not going to do this for everything. Oh, sorry. I minus 1. 1 minus 1, which is equal to the first value, which is just 1. B is equal to the current one, which is also equal to 1. The value of ops is equal to the max of 0, and 1 minus 1 plus 1 equals 1. So ops is 1. Total ops is equal to the sum addition of that equals 0 plus 1 equals 1. Now the nums of I, which in this case is 1, is added equal to nums of I, which is currently 1, plus the ops 1, so it equals 2. So now we have array is going to be 1, 2, 1 like this. Then we go to I equals 2, and we do the same thing again. A is equal to the value of the array at 2 minus 1, which is now 2. B is equal to the value at 2, which is 1. We do our ops is equal to max of 0. Hopefully you can still see this. Yeah, cool. 0 and a minus b, so 2 minus 1 plus 1. And that is equal to 1 plus 1, which is equal to 2. So our total ops now is equal to 1 plus 2, which is equal to 3. And our array actually got updated even though it doesn't need to, but the array here at this value is equal to nums at 2 equals 1 plus 2, and that equals 3. So we have our final array value is equal to 1, 2, 3, which is strictly increasing. Looks good. Feel pretty good about that. All right. Let's try running it and see how it goes. I'd like to do, how do we test it? Yeah, just run. All right, it passed the test cases, and you guys can still see this. That's good. I'm pretty happy about it passing the test cases. I think we should be pretty good as long as the array can never be empty, which even if it was empty, it would still return 0. And all the values seem to fit. Here's one question we might have to think about. What happens if you had 5,000 values and they're all 10 to the 4? Will that fit inside of integer memory? So that is kind of a quick edge case you should think about. So 5,000 is the maximum value times 10 to the power 4. And is that less than maxint? Because if it's not, we might have an overflow error. And so I don't think it is. That's about, what, 5 million? 50 million? Yeah. So 50 million is still should be safely under 50 million. And I think here int is like 2 to the power 16 or something like that, which should be safely under int 32 or int 16. Yeah, 2 to the power 16 is 65,000. Actually, it wouldn't fit that one. But for 2 to the 32, yes. And 16, no. So that's a good edge case to just think about. But I don't think it's going to probably matter here, especially since we're using Python, which I think defaults a 32-bit or 64-bit even. All right, let's try submitting it and see how it does. Come on, let's get it. Yeah. All right, it passed. Not the fastest one, I agree. It's because we're updating values inside of the array. We don't really want to do that. Let's think about optimizing this a little bit. Can we do this without modifying any of the values in the array? I think we could. But first of all, I'm very happy with the fact that we got this. I think in a tech interview, especially on-site interview, this is a great first start. You want to kind of get to this point with your interviewer before you start making any improvements, unless you just know them off the top of your head, which would be really cool. But the more important things is thinking about all these edge cases like empty arrays, overflows, whether it'll fit in memory. I think being able to kind of talk about understanding how the memory is used and stored and modified and the big O and the big O in space and so on, super useful. Trying to think about whether we could do any sort of math tricks. Let's look at the question again and see if we can do something. Maybe I should have really thought about this. If you add all the numbers, there might be some math where you just kind of want to make sure that if the first number is 1, the minimum it could be is 1, 2, 3. And you just take the subtract, you sum them all up and you subtract the difference between the two of them. That's one possible approach. So what I'm kind of thinking about, let me kind of draw it over here in this corner. So the idea is that, let's say we had, 1, 5, 2, 4, 1, 5, 6, 7, 8. Let's say this was like 10, 11, something like that. We know that the answer is going to have to be something like, the smallest amount is going to be 5, 6, 7, 8, and then 10 is safe and 11. So the only numbers that change are these ones, and we can figure that out by starting here and going until we just keep in mind that the amount of difference as you increment by 1. And then once you hit a number that's bigger, you can stop there. And then this difference is just the sum of the length of the array with that start. So it's like, I'm trying to think of the math for that one. It's like n plus 1 times n over 2. And then there's some interesting offset for the initial value, which you can just do like plus the initial value n of 0 times the length of the array. And, I'm not going to try to solve this in this interview right now, but I think that would be an interesting one because here you go O of n, you don't have to sum all of them up, you just kind of sum them all one by one, but you still end up with the same algorithm. That's what is kind of interesting. Still O of n time, O of 1 space. I think most of the optimizations would come from how you iterate through the array rather than trying to do these kind of tricks, but just for fun, I'd like to see what we have as options. Let's see what the other solutions were. How about here? Yeah, they do the same thing. It looks like they have their previous and their current, and they just increment if the value is less than that value, and otherwise they just keep on moving to the next one. I like that. That's really nice. Here they do the same thing as us, previous plus 1. I think it does help that they're just incrementing through the nums. one by one and then setting it that way. I like that a lot. That's quite nice. So one advantage of this one is you can take advantage of any optimizations in iterating Python's iteration through arrays when you do for num and nums. And then you just set the current value to previous to that current value every time. Any other interesting things? It's pretty cool. I think it's good to be able to kind of talk your way through these different options. That was fun. I enjoy getting back into doing puzzles again. If you were following along, were you able to get to this answer? Let me know in the comments if you were able to figure out the previous thing. I think that's really nice to do, and it'll save you quite a bit of time. We're talking like, tens of milliseconds. We're within the Python's interpreter at this point. I wouldn't really worry about this in an interview. The most important things to focus on are getting the big O correct, getting the edge cases and being able to kind of talk about it. I think it would be extra bonus points if you can kind of talk about this potential Mathy approach. If you're able to get the Mathy approach, let me know in the comments, because I think it could be really cool, but I'm not sure it actually saves that much time. Just having clean code, making sure you understand this kind of max operation. It doesn't have to be the max. You could do an if statement instead. Keeping track of total ops and this idea of counting from left to right. Were you able to get all of those things? Let me know. And if you like the chest detect videos, I'm still working on the next one. I'm looking forward to doing the UNet. I'm debating whether I should keep this on the same channel or a separate one. This channel, I might kind of focus on the algorithm series. I definitely really enjoy doing that also. But I also enjoy doing these puzzle questions. It's a fun way to learn different algorithms and see how people approach things. So yeah, I don't know. Should I keep this in the same channel or put it into a new one? If you have any strong opinions or even just any thoughts, let me know. I hope you enjoyed this, and see you all next time. Cheers.